between degrees and radians and degrees. We're going to talk about it again today. And we're going to talk about angles of standard position and coterminal angles. Because who wouldn't want to, you know what I'm saying? So standard position is when we sketch angles called rotational angles on the Cartesian plane with the initial arm where the angle starts on the positive x-axis. And then you go, for positive rotational angle, we go counterclockwise. For negative, we go clockwise. Okay? So positive rotational angle, I don't ever grab a pen. Good thing is I'm consistent. The bad thing is I'm consistent. All right. So draw our Cartesian plane. Now I'm just going to do these ones in degrees. So if I have 0 degrees, 90 degrees, 180, I always label my axis. So say I pick 300 degrees. That's positive, correct? So the way we do it is we rotate it around 0, 0, so we have to make sure we have that rotation. Bless you. And then we have an initial arm. That's where it starts. It always starts on the x-axis. And then we're going to have a terminating arm. Well, 300 is 30 away from 270, correct? Or 60 away from 360. So it's going to be somewhere here. Now, you may have gotten away with drawing something like that last year and calling it a day and saying that's 300. However, this is a positive rotational angle and negatives can exist. So what you have to do is you have to start here and show them that you're starting here and you're rotating around to here with an arrow. And that's 300 degrees. Now, what if I give you a negative rotational angle of negative 60? So we label our axes again, but we're going in negative direction, which is actually clockwise. So this is 0. This is negative 90 degrees, negative 180 degrees, negative 270 degrees, and then negative 360 degrees. Right? We're still rotating about 0, 0. So we still have a dot here. We still have an initial arm on the x-axis because that's how you get an angle in standard position. And then we have to rotate to negative 60. So we can either say, oh, negative 60 is 30 less than negative 90, or you literally just count to negative 60. Either way, it's here. Come on. And this time we go from here to here. And we write negative 60 degrees. What can you tell me about the coordinate on the unit circle at both those spots? They're the same. So we're going to have 1/2 and negative 3/2. So even though those are different angles, they're coterminal with each other. And coterminal means that they terminate on the exact same arm. So they'll result in the same answer. So what is sine of 300? What is sine of 300? Negative 3/2. Yeah. What is cos of 300? 1/2. And what's sine of negative 60? Negative 3/2. And sine of negative, or cos of negative 60? So instead of writing 1/2, could I just write cos of 300, comma sine of 300 degrees? Is that not the same thing? And this could be cos of negative 60 degrees, comma sine of negative 60 degrees. Make sense? So the terminal arm is where the angle ends, should have an S, and it can be in any quadrant or on any axis. Like if it was 270, you would rotate around and you'd stop at the 270 and you'd draw a terminating arm on the negative y-axis, right? All right. What angles correspond to each of the axes? We labeled them above already, 0, 90, 180, 270. So we're going to sketch these. Go. (40°). We have 0 degrees, 90, 180, 270. We're going counterclockwise because it is positive. So we go 0, 45 is halfway, so a little less than half, 40 degrees. This is 140. 0, 90, 180, 70, 360. It's 40 less than 180, a little less than half. 140 degrees. Well, then we have negative 240. So 0, negative 90, negative 180, negative 270, negative 360. So it's 30 less than 270. Be like here, here, rotating here, and out. Right. And then 340 is positive. 20 degrees shy to here, here. Now, is there an angle between this terminating arm and this one, this little short angle? Yeah, it'd be negative 20, correct? So if I don't draw any arm on this, or any arrow on this, I don't know what the angle is, right? That's why you have to show I'm going from here to here, and it's 340 degrees. Plus this here, we're not going to just stick between 0 and 360, we're going to rotate outside of that. So we go to 720, we could go to infinity for that matter, and do general solutions. Okay, so we go negative infinity to positive infinity. Next page. So, converting, we talked about this yesterday. I said to you that it was 360 degrees and 2 pi. We can write as a ratio because they're the exact same thing. One's in radians, one's in degrees. And then we can reduce that to 180 degrees over pi. Or we could write it as pi over 180 degrees. It just depends on what we're trying to get out of it, correct? If I want radians out, if I want radians from degrees, I'm going to put the degrees on the bottom, so I have a degree on the top, degree on the bottom, they cancel, correct? If I want radians to come, or if I want a degree to come out of a radian, I'm going to put the pi on the bottom, and then I'm going to be left with the degree symbol. So for example, if I had 30 degrees, and I wanted it to radians, I would times it by 180 degrees on the bottom, so that the degree symbols would cancel, correct? And then I put that pi up there, yes? But if I had radians, like we'll say just 2 radians, 2 rads, I would want to have a degree symbol at the top, so I'm going to leave this at the top, and then put my pi at the bottom, which I wanted to. I could put rads here to make it them cancel off, right? I don't have to have any actual units if it's radians. There is a little acronym, Dr. Pot, degrees to radians, pi on top, is what that stands for. So the pi would be on top. Should have a degree symbol. So sad that it doesn't. So degrees to radians, pi on top, and then RD-Cob, radians to degrees, pi on bottom. If you want to be a memorizer, here are some options. But better than memorizing is knowing that the units cancel off, and that's why the way they are the way they are. Does that make sense? You put that degrees on the bottom, 180 degrees on the bottom, you want the degree symbols to cancel off, 180 degrees on the top when you want to keep the degree symbol. Okay? So, for this one, 315 degrees. So I want the degree symbol, I want degrees to radians, pi on top, or I can say, hey, I want degrees to radians, I want the degree symbol to cancel off. So I'm going to put the 180 degrees down here, and the degree symbols will cancel, and then I have to have the pi on the top. Because you either have the pi on the top or the pi on the bottom. right? Doesn't change. Ratio just flips. Then I'm going to get 315 pi over 180. Because the degree symbol's canceled off. Then you need to reduce 315 over 180. Now, there is a catch. Everyone keep your pencils down for a second because I get this wrong on diplomas all the time. Sometimes the answer is an exact value, and we'll reduce the 315 over 180 and leave the pi, correct? But sometimes, and this is where everyone gets it wrong, if it's a numeric response, sometimes they just want the answer to the nearest tenth. They want it to the nearest tenth of a radian. So then what I get for the test, people will go 315 divided by 180, and they'll turn that into a decimal and keep the pi and just give me the decimal of what's in front. If I want this all in radians to the nearest tenth, what am I going to have to do? Include the pi. I'm going to have to go 315 times pi divided by 180 and just give me the answer. Yes? That pi doesn't stay out if they want it as just a decimal. Rarely is that asked, but I find that's when people make mistakes because they're so used to making exact values. So I want it as an exact value. So reduce the 315 over the 180. In your calculator, go. What do we get? Yeah. Okay, you guys try B and 3. Go. So we have 70 degrees. I want the degrees to cancel. I either do pi over 180 or 180 over pi. It's 180 degrees, so that the degree symbols cancel, so I know I'm right. And I put the pi on the top. And then when I reduce 7, I'll get 70 pi over 180. These cancel. And I'm left with 7 pi over 18. This one, if it's helpful, you can put rads behind it or you can put radians behind it. But radian measures don't need anything behind them. They're radians. So if there was ever a more important time to make sure you put a degree symbol, it is not more important than today. Okay? If your answer is 360 degrees and you leave off the degree symbol, you're actually telling me your answer is 360 radians, which is massive. And if you don't know what I mean, it's massive because 360 degrees is equal to 2 pi, right? Pi is 3.14, blah, 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 right? 2 pi is 6.28. So think about this. You do a full rotation of a circle in 360 degrees or 6.28 radians. Yeah? So what's 360 radians? My arm's going to get sore by the time I'm done. I don't even know, I lost track. But you know what I mean? A lot. Right? So you'd be like, well, Miss Lepp, then you know it's 360 degrees, obviously, because 6.28 radians is what? No, I don't, because you didn't put a degree symbol. Right? So, degree symbols are extremely important now. They were important before, you just didn't know how important. Now they're extremely important. All right? So we're trying to get a degree symbol because we're going from gradients to degrees. The only way to get a degree symbol is to make it be 180 degrees on the top, so we're left with a degree symbol on the top in the numerator. Yes? So therefore the pi must be in the bottom. The pi's can just cancel off in this case. And then negative 7 times 180 divided by 3 is what? Negative. Degrees. Right? Make sure you have a degree symbol. A lot of you drop the degree symbols off just like in perms and commas when you don't use the multiplication dots. Okay, this one's in rads. So I need to have rads down here, which is pi. Rads. Correct? The rads cancel. Then, oh, the 180 degrees must be up here. So type that in. Negative 1.4 times 180. What do you get? Negative. Pardon? Any decimals? No. Voila. We're going to bypass 4 for a few seconds here. It's like its own little island of information. Yeah. We're going to go to coterminal. Yeah. Oh, did we not divide by pi? Thought we did. What do we get? I was confused as to how that didn't turn out to a decimal. Negative 80.21? I was like, I thought people rounded it. So I was like, you have to have a decimal because you're dividing by a irrational number. But yeah. The woodpecker. It's just it's home for the winter. Don't worry. That's for sure. The woodpeckers. It's a family. Yeah, it's a clan now. Yeah. I think they've come together with another family. All right. Going down here. So, coterminal angles, principal angles, reference angles. We talked about reference angles. They're the acute, cute little angles that are between the terminal arm and the x-axis. I call them bow tie angles. Because some people try and do hourglass angles as reference angles. They make them form with the y-axis. That is not ever an angle you want. So we always want our reference angles, which are the bow tie angles. They're the angles between the x-axis and the terminating arm. And if you think about that, that makes a bow tie, correct? Boom, boom, boom. Take all of those. If you get an hourglass, we're doing something wrong because we never want them with the y-axis, ever. People are like, well, when do we want it with the y-axis? Never. So, don't. See? Easy. It's way better when you never want them somewhere than you just never do. Okay, always with the x-axis. That's the reference angle. Principal angle, we talked about this. And the principal angle is the smallest positive angle, coterminal with a given angle. And then coterminal angles, they just land on that same arm. We talked about that. We said 300 was the same as negative 60, correct? They terminate on the same arm. They would give the same answer on a unit circle. Yes? That's when you know they're coterminal. All right. I'm flipping over. Okay, friends. All I want you to do right now is sketch them. Sketch all four of these. Then we're going to get the reference angles. Then we're going to get the coterminal angles. Okay? I just want them sketched. Now, radians freak people out. What could you do if the radians freak you out? What doesn't freak you out? Degrees. So what could you do to this? Convert it. You can adapt to radians, which some of you will do, or the other people will just never adapt and they will convert it to degrees and draw it. Okay? It doesn't matter. But draw these. When you draw them, though, so for example, when I draw this one, I can convert it to degrees all I want, but I still have to label my axis in radians. Because the question was not asked, the question was not asked in degrees, so you have to draw it in radians, write all the stuff in radians, but you can convert it to degrees to actually sketch the arm, correct? But the whole question itself has to look like it's in radians. Try it out. Okay, so a hint to you. Radians, if they're ever, everyone paying attention? If they're ever over 3, they're a 60-degree reference angle on your unit circle somewhere. If they're ever over 6, they're a 30-degree reference angle somewhere on your unit circle. If they're ever over 4, they're a 45-degree reference angle on your unit circle. If they're over 2, they're a 90. So if ever your radian is over 3, 4, 6, or 2, it's on your unit circle. You don't have to convert it. Just look at your unit circle because you probably have drawn it, right? Go look for it. So that's a hit. Okay, 60 degrees. I go 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360. So I have to draw my rotating. Went back to this thing. So initial, terminal, 60 degrees. Sure, stay there. All right. 5 pi over 3. What is that? Pardon? This is the same as 300 degrees. Can 300 degrees appear anywhere on here? So what happens is you guys will convert it to degrees because you like degrees better. Even as much as I try and make you not, you will. It's like, it's just, you're like, I just live in the degree world. I like it. Cool, great, love that you live there. It didn't say anything in degrees though, so you can't live, you can live in the degree world to draw it, but nowhere on there can it look like you lived in the degree world. You know what I mean? Like when I look at it, you can leave the 300 degrees there. I don't mean like you have to hide everything, but I just mean like when you're drawing it, when you're saying anything about it, you have to keep it in the radian world, okay? Degree world to help yourself, but nowhere can it look like you actually lived in the degree world, okay? So I know it's 360 degrees, so I know it's 30 more than 270 if I'm living in the degree world, which means it's here and here, and I draw this, and I don't say 300 degrees. I don't put my axis in degrees. I put them in radians, and I write 5 pi over 3. See what I'm saying? I can convert, but my whole thing has to look like it's in radians, because guess what? The question was in radians. Okay, same thing here. So, I'm going to go 0, and then negative pi over 2, then negative pi, then negative 3 pi over 2, and then negative 2 pi. Still have an initial arm here. Okay, what is negative 2 pi over 3? Negative 120. So it gets me to 180, or 30 more than 90, so I know I'm going to be here. Come on, draw the color I want. And then arrow to here, and then I don't write negative 120, I write negative 2 pi over 3. We agree? So nowhere on there does it look like I did any degrees-ness. We'll learn to really be excited when you see a degree symbol. Like, yes, this is where I like things. So this is 0, 90, 180, 270, 360. Here, and then we're 30 more than 270. So, 300. And we have negative 135. So I go 0, negative 90, negative 180, negative 270, negative 360. Negative 135 lands in the middle because it's a 45-degree reference angle. I get negative 135. Oh boy, what's going to happen with 750? It's going to keep going, right? So we have like 0, 90, 180, 270, 360, 450, 540, 630. 720. Oh my gosh, I'm on arm twice. Right? You agree? So I'm going to start here, and I literally can just count. Okay, cool. 90, 180, 270. You see if I label it, it's a lot easier to figure out what the heck I'm doing. 90, 180, 270, 360. I felt Italian for a second there. 90, 180, 270. No? Okay, cool. That's Friday. 360, 450, 540, 630, 720. Then I have to go how many more? 30. See how labeling the axis can help you? Right? That is it.